moving on, as I've shown you earlier, I've already input these files, and in this folder, the project folder, I have these 3 folders for the inputs, and whatever is generated in the session within QGIS will automatically populate in these subfolders under the session folder. So this is just so that everything is nice and tidy. And of course we have the .qgz file, which is the actual QGIS file. So I'm going to go ahead and open that now. That's some error which comes in, but it's seems to work okay. QGIS is a bit glitchy, but it's a super powerful tool, and it's free and open source, and we have the good people who have worked on QGIS and the plugins which they've created to make things better. And here I'm contributing to this cause by also making some workflows and scripts which you can buy from my website. In that way you support me as well, and I'm sure it is going to give you a lot of save time and a lot of quick analysis outputs. So now, having opened QGIS, I've already loaded in the orthophoto. Now, of course, if it's not loading, I would just click that certain layer and click this button. It'll zoom into that piece of land. So as I mentioned earlier, the first step in all of this was to walk around the property with a precision GPS device. Now, for precision GPS, you need an RTK device, which will give you sub-meter level accuracy, and in an open canopy, you can get up to centimeter level of precision. So that is essential. You could use something like a Garmin, but the workflow is really terrible to export it from Garmin and getting the file and formatting right and then importing it into QGIS. It's a little bit of a task, and you only have the device interface to work with, which is not great. So I think Garmin has moved past its prime and relevance. Now you have RTK devices which interface with your phone. And because you have your phone and there's a UI with apps, I've used SW Maps interfaced with a GeoNet GeoMeasure device, which is the RTK handheld torch, to arrive at these initial tracks, walking tracks. So the first step was, as you can see here, I walked around the property, and then I needed to get the drone mission. So from these tracks, I needed to get a fixed polygon so I could feed it into the drone mission planning software and then fly the drone. So that's what I've done here. Now, as to the how of making this drone flight polygon, in QGIS you can't directly make a GeoJSON file, and GeoJSON is the preferred sort of format to use for anything shape related, which includes polygons, which includes points on the map. QGIS has various outputs it will make as a result of you creating a layer, but GeoJSON is what is recommended, so that you can also use it for Python scripting and other things along the way, which I will show you in a bit. So let's say you didn't have this polygon outside and you're on field. You should have carried your laptop. You've now exported the walked path, which looks something like this, into QGIS. From here, what do? You go to layer, you click on create layer, and you create a new shapefile layer. Give it a name and make sure it is in the correct folder, of course. In my case, that is in here. I would go to inputs, and actually I would just go to the sessions and go to GeoJSONs, because as I mentioned earlier, I like to keep things uniform so that when you're working with multiple projects, you don't need to sort of be presented or met with a chaos of 100 odd files. When everything's at its correct place, it's easier to work. So I would store it in the GeoJSONs folder, and let's just call it GeoJSON drone example. And as you see, it creates a .shp file. So let's create the save there. And the geometry type, I'm going to go with polygon and click OK. So now, having done that, you see that this is the selected layer. It's got a pink fill on the inside. And now I'm going to add the points to make that boundary for the drone flight. So with this layer active, I'm going to click on toggle editing, and then I'm going to click on add polygon. Once I click that, I will add various points along the way by left clicking. And as you see, there is a selected area indicator you get. And now, of course, I'm just doing this for rough, so you can be more precise, and that will help further in the workflow as well. But here I'm just trying to show you how this is done, and you right click to finish it, and you can just hit enter, and then you have your polygon. Now as you can see, this is currently filled in with that pink surface. Later on in the processing, we'd ideally want that to be see-through, and we just have a nice boundary polygon. So once you have this polygon, you can just save the edits and click on the pencil icon so that it's saved. And when you hover over it, you'll see that this is a .shp file. From there, what you want to do is right click that layer, hit export, click on save features as, and then the format automatically shows up as GeoJSON. And now again, you give it a file name. It is in the same folder, fortunately. And so we're just going to go and put drone flight path example.geojson, and I'm going to hit save. Now remember that this works well only if you've made a couple of points and you've created a polygon. If it's an empty file, this export step will fail. You can leave everything else as it is and then just click on OK. So now we see that the layer has been exported successfully to that path and a new layer has been created. Now, when we go and look at the actual folder, we will see that we have a lot of files which have been created. Now, all of these are redundant. All of these, which we start with the .shp file as shown earlier. We can just go ahead and delete the whole lot because that is irrelevant for us, including this QMD file. The QMD file and the GeoJSON are saved at the same time. So there's two formats when you export to a GeoJSON. I'm just going to go ahead and delete the QMD file. So we're left with just the GeoJSON. I'm just going to go ahead and delete these files which I used for an example. We're going to remove these layers and we're left with this drone path, which is what I actually prepared on the field. And let's move ahead with this. Okay, so now I've cleaned up the workspace a bit. I just have the relevant layers here. And now we're going to go ahead and look at the ODM orthophoto, which is the RGB orthophoto. Now this, as I mentioned, is a map which is created by stitching several images together. In this case, it might be about 100 or 200 images. And this gives you a lay of the land. And you will notice that the sides are distorted after the photogrammetry process which created this. But this is expected because for it to get a proper detail, like here, if you notice this tree, this is the orthophoto, means it's orthographic, in orthorectified. It transforms each of the objects on the map as if it is being looked at from a perpendicular angle from the top. So it is a direct top-down view. And it makes these corrections for all of the objects on the map. So each image you zoom in, it should show up as if it's been taken immediately above it. And this is through some trigonometric, photogrammetric magic, which we won't get into too much here because there are several tools for it. I myself have used an open source tooling for this called WebODM. But yeah, it is expected that the sides are blurry because we fed this boundary to the drone while doing the mapping mission. And then it is not taken sufficient images on the other side at the boundary edges, and hence that's blurry. And it'll always be blurry at the end of a drone mission because there's always going to be that last outline of pictures where it doesn't have the corresponding image on the other side to give you a proper triangulation and orthorectified image. So we will anyway be cutting off these sides and we'll be left with only this relevant area, which we're going to use for our area calculations and preparing the final map and other things. Okay.